think most of you know Matija, but those of you who don't, Matija is at UCL getting his PhD, and he's soon to be coming on at AOI as a researcher. And one of the things we helped Matija with was the blame game. So he's going to tell us all about it. And Matija, take it away.
Hi, everyone. Okay, cool. So yeah, as I said, because most of you seem to be in the room, I'm very happy to stop along the way so that we can make this more of a conversation. But yeah, as Brittany said, today I'm going to be presenting the blame game. The way I've roughly structured this presentation is the first half is going to be more about like the context and the theory behind it, because I think it's equally as interesting. And then we're going to focus on the study itself and some preliminary findings that we got. So the blame game, more broadly, is a study that is trying to understand people's legal reasoning to autonomous artificial agents. This is not the first time that people have had to face artificial agents within the context of the legal system. Companies, organizations, and governments are previous examples of agents that have legal standing and that people have differential legal reasoning towards, but that's kind of the broader context of what's going on here. So the interesting thing about autonomous artificial agents is it brings about this problem of many hands where the AI agents themselves are not the only new agents that can have blame attributed towards them. So apart from the AIs themselves, there is the creator or the manufacturer of the agent. There's the user. There's the data set that the agent was trained on, which surprisingly, people catch on to and are very happy to treat as a agent of blame or sort of legal stature. The provider of the data set, and in some cases the hardware with more embodied systems. And there are many examples of this, and sometimes examples are not legal in nature. Sometimes they're situations that people like attributing blame to, even though there's a legal standing. But people have had many conversations about these things publicly, and these things have been studied in the lab. How do people react to self-driving cars running someone over, or various predictive algorithms assigning who should get arrested or what grade somebody should get or who should get hired, things like the crash clash. So there's many different examples of this. And basically the sort of like context in which this is being studied from a cognitive science perspective is that of attribution. So people have this rich system of responsibility attribution that allows them to hold individuals responsible for their actions and assign brazen blame in complex social situations. And one of these sort of crucial precursors to assessing responsibility is our ability to have a model, a causal model around the world that allows us to explain agents within it and why they do what they do. And it allows people to infer the hidden beliefs and intentions behind the actions of different agents within a setting, and to tell a story that makes sense of social behavior more broadly. There are certain challenges to making legal reasoning and therefore attributions towards it. They don't naturally fit into what we usually use as standard legal classification. While AIs are capable of learning and making autonomous decisions, they lack certain typical human qualities, or at least are perceived as to lack them. And to tackle this problem, various proposals have been made as to how AIs fit within these current schemes. But this is not what we're going to be focusing on today. The present study is trying to develop a methodology that is going to allow us to understand people's legal reasoning towards AI agents, and also how these things change over time as people get more information about these systems. So before we sort of get into the framework that we're going to be exploring and then the methodology, I'm very happy to stop here if anyone has any questions. If not, I'm just happy to continue. Continue?
Yep.
Okay, so this is the framework that I ultimately want to explore with the blame game. As you will see later on in this presentation, we've started off with exploring one of these squares. So we have internal factors, external factors, contextual factors, and outcome factors. This division is blurry in certain ways, and there is a lot of overlap, but it is just a sort of useful way to think about how some of these factors differ, although it's not, in the modeling itself, it's not that important. It's more of a sort of like explainable layer. So I'm now going to initially go through these different groups of factors and talk about them a bit before we get into the game and the methodology itself. So starting off with the internal factors, which is what the focus of the study was, the initial study. First of all, we have intent. So intent influences blame attribution in this very simple way, in that actions that start off with intent, intentional actions, are blamed more than ones that are not. And intention in many ways is seen as the beginning of a causal chain. And this is one of the ways in which it relates to our mental models of different legal situations. Intent is obviously used in jurisprudence and also the legal system. So in America, there's the Model Penal Code, and activities that are seen as most blameworthy and those that deserve the most sentencing are those that are done on purpose. So there was an intention to bring about a certain outcome. And what's interesting is that intent has many gradients. It's not as simple as a 0 or 1. People can do things knowingly, recklessly, and negatively, and all of these things are more or less intentional, with purposely being the most. Current research suggests that people view intent as something that is more important in their judgments of other people. So in general, people put more weight onto this factor when assigning blame or responsibility towards other humans rather than machines. And people also infer more extreme intentions towards humans and more narrow intentions towards machines. There's also been more normative work recently about developing definitions of intent that are appropriate for machines, but we'll skip that for now. We then have a very sort of like similar concept, but uniquely different, which is that of desire, and maybe aim is a better word in the context of looking at machines and AI agents. So desire and intent is conceptually different in that intentions involves committing to performing the intended actions, while desires do not. So intentions are necessarily something that we act on, and we don't always act on our desires. Intentions are based on reasoning, while desires are an input to this reasoning, and desires can be directed while intentions are directed at the intender's own actions. And desires, like with intent, influence blame attributions and our legal reasoning. Then we have knowledge. Knowledge relates to the degree to which an agent has the knowledge to subjectively foresee the outcomes of its actions. Agents are, of course, to blame more when they had foresight over what the outcomes of the actions would be, rather than when they don't. And in legal context, predictability is assessed relative to a reasonable person standard, with people being held liable or responsible for harm if a reasonable person could have predicted the outcome. This also, in a sense, relates to objective foreseeability, which we'll get to later. But this, rather than looking at whether something could be foreseen from a reasonable person standard, tries to take a more objective measure over whether something could be foreseen in a situation. Then we have effort to learn and effort to prevent. These are actually factors that we don't know a lot about. These are contexts that are novel to this exploration here. But in a sense, effort to learn can be viewed as something that plugs into knowledge. And it's interesting to ask, if someone doesn't have the knowledge to predict the outcomes of their actions, did they make any effort to learn that? So is it the case that they cannot foresee because they didn't make an effort, or they made an effort and still weren't able to foresee the consequences of their actions? And then in line with that, we have effort to prevent. And again, it plugs into knowledge in that if someone has knowledge to foresee what the consequences of their actions are, it is interesting to ask whether or not did they then try to prevent this outcome. We then have capability. Capability differs from knowledge in that it is less associated with people's ability to predict, but more with a task-specific capability. So as you'll see later on, our initial exploration was looking at a crime that relates to self-driving cars. So in this context, capability would be related to how good of a driver someone is. This factor is quite controversial in that it produces different findings, and we still don't really have a grip of it. So certain people have previously found that people will blame the skilled. So if somebody is more skillful in a certain domain, people blame them more because they're viewed as agents that have more control over the situation. So capability might relate to control in certain ways, or causality, which we'll talk about later as well. But then also there's been other research that has found quite the opposite, that people that are low in skill actually get blamed more. And that's actually what we found in this study, and we'll get to that later. But capability is also quite confusing. For the sake of time, I'm going to skip through character. It's a bit less relevant for the present study, but it sort of relates to how people perceive a person. Do they perceive them as someone who is responsible or responsible, friendly, unfriendly? All of these things, people's perceptions of other people's characters play a role in how they assign responsibility to them. The reason why character is difficult to study in the lab is it's very difficult to experimentally induce a sense of character. towards someone. One way of doing it is through association. So in the context of AI, characters usually associative. People have attributions about the character of the company or the lab that is making these systems, and then that sort of gets modeled up. So that was sort of internal factors. Now we're going to move into the other three groups. I'll do that a bit more quickly because again, they're not the main focus of the study that I'm going to be presenting today. But we have external factors. There's autonomy. Autonomy in many ways is the reason why studying legal attribution towards AI agents is interesting. They are interesting because they have autonomy. They have an ability to make their own decisions while performing a certain task. And autonomy is heavily related to control, like capability. And people attribute blame in terms of an agent's control over the outcomes over its own actions. So it's heavily related to causality, as we can sort of see in this graph. And there's been some interesting work done on machine autonomy. So higher machine autonomy is associated with intent inferences towards autonomous artificial agents. When robots are described as autonomous, participants attribute nearly as much blame to them as they do to humans. And more autonomous technologies decrease the perceived control a user has over it, which in turn decreases the praise a user receives for positive outcomes. And then there's also interesting stuff like drivers of manually controlled vehicles are deemed as more responsible than drivers of automated vehicles, which might relate to later findings about how the user of a self-driving car is viewed differently from a user of a manual car. We then have causality. Causality is quite a central factor, as you've noticed up until now. It relates to intent, is in that it's viewed as the beginning of the causal chain. It relates to capability and autonomy. But one famous framework, the most famous framework on causality research, proposes that people assign blame, they prospectively determine an agent's criticality. So this is the extent to which an outcome is dependent on an agent's action. And also then retrospectively, they could determine the agent's pivotality. So the causal contribution of an outcome. So we have dependence on an agent's actions, and then we also have causal contributions. There's two different types of causality. And then finally, we have role. Role is quite interesting. A lot of research has been done on it in the sort of human-AI interaction world. People have sort of created these maps and frameworks of the types of roles that exist out there. One proposes that an AI currently, in how it's currently being used, can take the role of an advisor. So that's sort of like a recommender system. It can be your partner, right? You can clearly work on it on something. You can delegate something to it. It can be a role model. I guess an example of role model is people learning from AI bots to improve their chess skills. And then also other frameworks have proposed things such as AI bosses, so the Uber algorithm, and then also AI adversaries. So when you compete against them in a game or in a different setting. But then moving on, for the interest of time, we have contextual factors. So contextual factors are things such as the context itself. Today, we're going to be looking at self-driving cars. The future of the blame game is going to be looking at other contexts. Things like additional causes. Additional causes are hard to study experimentally because the combinatorics become quite messy, and other agents that might be involved in the scenario. This is something that we're definitely going to explore today. We have something that I've referred to previously, which is normative or objective foreseeability. This doesn't take a reasonable standard, but it looks more at what people think somebody ought to have done, or whether there was sort of a more objective way at seeing whether something could have objectively been foreseen in a situation. And then finally, we have outcome factors. Outcome factors can be the outcome itself. It can be the behavior that led to that outcome. But then also, interestingly, sometimes the behavior and the outcome gets tied up into the same thing. And this is the case with culpable actions. Culpable actions are things like lying, cheating, stealing, where irrespective of the outcome, even if the outcome is quite low in its magnitude, quite low in how negative its valence was, they're still greeted with blame and with high responsibility ratings because the activity itself is seen as a culpable action. So I guess that was sort of like the theoretical background. We're roughly now on the middle in terms of time. I want to leave I want to leave 15 minutes at the end so that we can have a proper discussion. But I guess at this point, it would be good to ask if anyone had any questions about the framework itself.
I'm curious what these arrows are like. Do you see these as traceable or phenomenon?
So the errors in outcome factors?
Or between the factors as well. Like
Oh, the arrows. Sorry, I heard arrows. Yes. Okay. So yes. So these arrows currently are a mapping of what prior research has told us about these factors. The ultimate goal of this study is to see what this mapping would look like when all of these things are studied at once. Most of these things have been studied independently or maybe with two or three factors at once. And the goal of this game, in a sense, is providing an entertaining environment where people are happy to deal with more than one or two factors in the same study.
A slightly different question is, I'm interested in understanding, and this may or may not be relevant for the AI thing, but like, why do you think like character plays a role? Like, what exactly is
Another question, roughly.
Yeah.
Yeah. So character's super interesting. As I said, it's like very difficult to study experimentally. A lot of the work on character has been done in philosophy, but then the experimental work that has been done suggests that people build these sort of like impressions about a person's character that cannot necessarily be reduced to their opinions about their capability or knowledge, but more to do perhaps with their personality or an amalgamation of their previous behavior and actions. So it's almost like a prior on what they expect of them. What do they expect them to do given their character? The reason why I've avoided it as a factor is because I think that maybe a better way of understanding it is almost like some sort of like Bayesian prior of like what your expectations are of someone. But the literature at the moment mostly calls it character. That sort of
Right. So it's shaped more like uncertainty, right? Like character plays a role because we don't have full access to the mental episode that generated the behavior. We don't exactly know the desire or the knowledge or the intent. So we use character as a way to approximate around of the uncertainty, right?
I think that's right. Yeah.
Right. So like as systems like get their own identity in some sense, like in a social sense, like GPT or Bing has its own identity. People will also form some impressions. Oh, like it has done these things in these previous instances. So I can form these associations, right?
Absolutely. Yeah, absolutely. And I think that's why character deserves its own study. I think it very much requires more sort of like longitudinal analysis. It cannot be done with the methodology I'm using here, where people are sort of assessing evidence in a one-off way. But yeah, it will be interesting to see what research comes out in the next couple of years in terms of, do people assign character based on their experience with something like Replica or ChatGPT or Bard? I actually know of a person that is doing their PhD in this area, so it will be interesting to see what she comes up with. But I think increasingly character is gonna play an important role. I think maybe prior to people's opportunity to sort of like interact with these systems more, it could have been the case that character was sort of associated with the developer. So I don't know, like people would often refer to as like the algorithm on like social media, on YouTube and things like that. And I think in many ways, like there was a character for association where they would attribute it to their perceived character of the company that made it. But yeah, I don't know. What's your intuition here? Do you feel like that is true, or do you think that it's more that there is another element to it that goes beyond the company or the developer?
I do think like in some sense that happens, and in some sense it's also justified. Like if you like in like there is a sense in which one of the mechanics that I think you also like tangentially pointed to was like like something about like you should have known but you did not, like negligence. What could have been a foreseeable negative effect becomes an unintended consequence, so you deserve blame because you should have done the effort to actually foresee it. That is a thing that like is in some sense both like has its causal trace across the developer and the system. Like the developer could have foreseen the algorithm's negative effects, but did fail to actually do so. And therefore, like if the algorithm is negligent in some way, then that negligence also is inherited by the developer in some sense, right?
Yeah, that is an excellent point. Yeah, I guess like what one could that would be a way in a sense of studying it in a one-off way, looking at these different levels of the model penal code and viewing how like expressions of it end up going back to character inferences. Yeah, that's a good point.
I have another question, which
Mhm.
is about what is the distinction between capability and knowledge? Because it seems to me
Yeah.
that what you're referring to with capability can be treated as know-how. Like what in like epistemology would be called like know-how, or like knowing can be treated as a form of knowledge. So you like everything that you said about knowledge could be also applied to be capability. You should have foreseen the outcome if you fail to do so. Can also be converted into you should have become more competent at this before actually trying and like catastrophically failing at it or something. Ability and knowledge seem to be very conceptually adjusted.
Agree with you. What this map represents, in a sense, is just my best ability to pin down the research that has happened today. And the research today has treated these things as separate, but I think like studying the overlap would be really interesting. I guess like my empirical answer, I guess in a sense, is that for some reason, both in this study here and in other studies, when these two things are studied by side, they produce their own unique effect sizes. People get this extra bit of something from knowledge that they didn't get from capability, and vice versa when you look at the ordering in which they've been picked up on. But I do agree that I guess philosophically the lines are very blurry, and ultimately your capability, let's just take driving as an example, because that's what we're talking about today, will impact your ability to foresee. So it is very related to knowledge. Yeah, like I mean, potentially this setup can be used to understand this in more detail. Maybe like, I mean, yeah, this is the thing we're going to get to it a bit, but because of the combinatorics, this game treats the factors it is studying as binaries. You either have or you don't have intent. You either have a high capability or a low capability. But the only reason why that's the case is because I'm studying a lot of factors at once. What would be quite interesting is to take this same setup and only take two factors and really dive into them. And one example of that could be looking at capability and knowledge in a more granular way and trying to really get to terms with what are these sort of like unique bits of knowledge that people get that impact their final sort of blame judgments.
So I think the reason I'm pointing out the parallel is I think like you said, capability has this weird thing where like sometimes people tend to blame more capable agents, sometimes people blame more like less capable agents. And I think like maybe what is happening there is some conflation of like something around moral patienthood and compassion or something. Like if a company is not competent and is trying to do something it is not competent at, I would blame it more because it's like you ought to have done better, not try things you don't know how to do. But if a human being is like trying something and failing and like you're like, oh, like you failed and like I don't know, like a child like is trying to do something, breaks a glass, you're like not gonna blame because like, oh, like you also care about the agent in that sense. Like there's also so that there's not just the calculus of moral agency and blame there, there's also like the calculus of like there's moral patience involved, there's compassion involved, etc. etc. So maybe the flip that one sees in like low capability being more blameworthy or high capability being more blameworthy has to do with this phenomena, whether the agent itself is a moral patient or deserving of compassion or not.
Yeah, it's super cool that you picked up on that. So in a previous study, that's not this one, we definitely have found that things like capability and assigned role are factors that matter more to people when judging the behavior of machines, while things like foresight, in this case knowledge and intent, matter more when judging human behavior. And again, yeah, I think it relates to this intuition of like, yeah, like allowing people to learn and to make mistakes versus like, yeah, like this expectation that whatever gets deployed as a machine should just like meet a certain capability requirement or threshold rather. But yeah, are you happy for me to move on? Yeah, just for the sake of time. But yeah, that was super interesting. I'm happy to come back to that later. So yeah, we have the blame game. Everybody can play it at blamegame.io. But basically, the primary goal of the blame game is for participants to take a role of an investigator who's examining a case involving a car crash. Later on, we're going to have more scenarios. Those are very much ready. The agent involved in the crash is either a human taxi driver or a self-driving car. The objective is to gather relevant information by exploring 5 factors. So in this case, the ones we went for is intention, capability, knowledge, desire, and effort to prevent. And for the initial version of the game, people had to gather information about all 5 factors. Later versions of the game will allow people to gather less information and make their final judgment earlier. And people are allowed to pick the order in which they gathered the information, which will become relevant later when we look at some of the analysis. The game adopted a sort of like classic visual novel format, which combines interactive storytelling through text and images. All the gameplay sort of happens via text. And we used a generative approach where we use our 5 factors plus the 6th factor of whether an agent is a human or an artificial autonomous agent. When you see AIA, that's what that means, artificial intelligent agent. And this allowed us to sort of like use text and images in a structured way to generate 64 ways in which people can experience this game, which will become relevant because it allows for a fair amount of replayability, and we'll talk about some of these things later. So yeah, I mean, this, and if anything, just sort of like adds to what I said before. So we have these 6 factors because of the combinatorics of it, because we wanted to explore quite a lot of factors, much more than a lot of studies usually do. We had to treat these 6 factors as, so in this case, an agent type is a human agent or an artificial autonomous agent. They either had intention or didn't have intention. Capability could have been high or low. You get the point, right? So they were binaries. And thanks to the generosity of the AI Objectives Institute, we were able to get a sample of over 2,500 participants for this initial study, which allowed us to get enough participants per experimental group to properly do some analysis. Oh, okay, this is more blurry than it was on my screen. Now that this is full screen, but this is sort of what the game looked like. You're given this scenario. So in this case, a taxi was driving through a busy intersection and hit another car, injuring the person in the car it hit. There was no passengers in the taxi, and it was on its way to pick up the next passenger. The taxi was driven by a taxi driver. It is not clear why the crash happened. So there are a lot of details here that I can talk about. I'm going to point out a few. So this vignette used to be a different way. We've gone through a couple of different iterations of it. We did some user testing at the AI UK Summit organized by the Alan Turing Institute. So it was quite important for us to have a vignette that was vague, that made people feel unsatisfied with the amount of information they are getting, so that they're then motivated to go and get more evidence. We wanted to make sure that there was no passenger in the taxi because it makes things a bit simpler. There's just the driver and the car, or in the case of the self-driving car, it's just a self-driving car. Things like the busy intersection, things like that, it makes it a bit more vague, and it makes it slightly less clear why the crash could have happened. We later tested for whether people used the image itself to inform parts of their judgment, and overwhelmingly they didn't. So that's a good thing. This is the self-driving car version. So yeah, the same text, but it's a self-driving car. And then people could essentially ask these 5 questions. This is sort of the gameplay part. The nice thing about our setup is we can plug in other factors in future versions. So we've started off with these factors that we previously described as internal factors, but in future versions of the game, we can look at other things. And when people ask the question, as I previously mentioned, the game would either randomly generate a 1 or a 0 row. So in this case, the self-driving car didn't want to injure the person in the other car. One important thing to point out is that people could update their judgment. So this sort of, what's the word I'm looking for, scale below would be at the same place they left it last time. So if now I was to make a judgment of 30, when I would get to the next bit of information, the scale would start at 30. So we wanted it to feel like people were very much getting new bits of information and updating their judgments. So do you have any questions about the game design and the gameplay itself before we move on to the results? Was that all clear? Is there anything that you felt like I left out?
I have a question about this particular slide.
Great.
So I think like the particular way that you phrased it, the self-driving car did not want to injure the person.
Yeah.
Makes me like how do we even conceive of desire in AI systems? Like, what does it mean for an AI system to want? Like, and
Yeah.
like we could cook up some like concept that might make sense, but like the people filling the survey may not even have a coherent notion of like what does it mean for an AI to want or something.
Yeah. No, that's exactly right. Yeah. And I think so. The wording here, as you can imagine, was, this is what took the most time in terms of coming up with these things. Because again, like going back to the conceptual side of things, desire is related to an outcome, while intention is related to an action. So if this was intent, it would be the self-driving car didn't intend to crash into another car. Yeah, so I mean, we tested many different ways of phrasing this, and this is the one we landed at that the most people were comfortable with and sort of reacted well to. An interesting empirical finding in its own right is that just people care less about desire and intent when it comes to artificial autonomous agents, and that indeed is the case, as we'll see in the results. One other wording that we used was aim. There's this one researcher that was one of the people that collaborated with me on this project called Hal Ashton, who has done a lot of work on algorithmic intent. And what he ended up conceptualizing was that the closest thing we have to desire in AI systems is aim. So desire can be sort of like an aim of sorts. The problem we had when we used the word aim is that then desire felt too similarly to intent. So we ended up making this methodological decision, basically. It was more important to us to have something that felt sufficiently different from intent. And I think we did achieve that, because later on you'll see there are interaction effects between desire and intent, which means that they're both producing their own unique effect size. But yeah, I'm definitely open to exploring other ways of wording this. In general, a thing I should have probably pointed out, I'm really glad that you asked this question, is we allowed people to report to us if this evidence didn't make sense. So in general, we wanted people to have the ability, if they think that an AI system just isn't able to want something, they could tick this box. And hopefully that evidence, once we analyze it, will reveal some of these assumptions people have. How do you think you would word it out of interest? Do you think there's a way of wording it in a way that would make more sense for a self-driving car?
I'm not entirely sure how I understood it, but I do think that like the thing that you communicate here is whether the self-driving car was trying to, like something like whether the avoiding the injury was part of the objective function or not, versus whether the avoiding the injury was part of the policy or not, right? But like that still like is me trying to understand it in terms of ML terminology, like what you're conceptually trying to point to, but I don't know how I design the public survey here.
Yeah. So no, in terms of like the prevention of injury, that was more this sort of like, could the taxi driver, no, not foreseen, sorry. Did the taxi driver make an effort to prevent hitting the other car? That was in the human case. So that was different from desire. But yeah, I mean, basically, to make a long story short, we did loads of user testing to just sort of like try to get at what we wanted to get at. And this sort of like met the criteria of allowing us to get something that people thought of as different from intent, while not overly anthropomorphizing. But I agree that it's not perfect. Like we'll definitely explore different wordings in the future, and maybe also even versions where half the people get one phrasing, the other half get another phrasing.
Jump in there and kind of, I think that like I worry that, I mean, people do anthropomorphize fairly for AI. Making the language very concrete in this way may kind of throw people off, and they may be less willing to admit to actually engaging in that type of behavior when making a certain judgment like this. And to use like a toy example that's even more extreme, let's say that a car ran a red light while going to pick up pizza, and for the human driver, you learn that like the person was super hungry or not super hungry, and like does that matter when you're making a judgment of blame? And you can also ask like, oh, was the self-driving car hungry when it ran the red light? And it's like, well, obviously no, like it doesn't feel hunger, it's not an experience. But as TJ was saying, like if you reframe it as like the injunction is like there was a very strong motivation to reach that particular goal, does that matter at all? We call that hunger for the person going after the pizza, but I want to make sure that we're like using terms in a way that we don't miss out on some effect that might actually be there if we kind of get things on the same verbiage.
Yeah, absolutely. Yeah, I think like it's interesting, like using more sort of like technical description like that might alienate potential participants, but I think it would be super interesting to put it to the test. And ultimately, like the whole point of this initial study was to be able to essentially like test out this method in full and validate it, which we now have done, and then to sort of launch this platform that will just exist online and collect data over the course of a year. And I think it would be really interesting as just like an additional factor to use these different wordings for things like desire and intent, and just see what happens, and see how people react to this. Maybe we can even have an additional box that people can tick that relates less to this doesn't make sense, and maybe relates more to I personally didn't understand what this means. So yeah, there's definitely ways of getting around this. Yeah, I'll definitely take that into consideration for the paper design. Cool. For the interest of time, should I move on to the results? So I'll try and skip through the ones that are slightly less interesting, but in general, initially, before people get the evidence and they just read the scenario itself, people do just sort of like assign more blame to the autonomous artificial agents, but this difference disappears completely after they get more information about the setting, and is obviously higher than the initial judgments were. We did separate analyses for different factors, and then later analyses focuses on the factors combined together. The way we explored the role of factors is we explored whether there were differences in judgments by agent following their encounter with the information on the first factor they've encountered. So this was in cases where people pressed on that button first. So they wanted to know about intent first, or they wanted to know about effort to prevent first. And then we then juxtaposed that with what their final judgment was in cases where that was the first bit of information they were exposed to. So in general, we saw that for the first blame judgment, there were higher blame judgments when an agent had an intention exerted more substantial impact on blame attributions towards human agents. And this escalation was perceived blameworthiness was greater when human agents exhibited intention than when artificial autonomous agents exhibited intention. And for the final blame judgment, there was still a main effect of intention. So even after all the other evidence, the agents with intention were just perceived as more blameworthy in a way that was statistically significant. Then when we look at desire, there was a clear main effect of desire on the first judgment, leading to notably higher first blame judgments when an agent possessed it. And this effect, unlike for intent, disappeared in the final blame judgment. So the effects weren't significant when people reviewed all of the information. We then have ability. So if the event could have been foreseen, participants showed markedly higher blame attributions compared to those that didn't. Participants exposed to the artificial autonomous agent scenario consistently regarded the agent as more blameworthy in comparison to those who were presented with a human agent scenario. So unlike intent, in this case, it had a greater effect on the AI, the self-driving car case. And for the final judgment, neither of these main effects persisted, so more similar to desire. We then have capability. So in line with your intuition, agents without the capability to avert the outcome received more blame than those possessing the capability. And for the final blame attribution, this main effect still held. So agents with low capability, no and yes is technically wrong. It should be high and low. So agents with low capability, and there were no agent effects. So this wasn't more so the case for humans or AIs. And then prevention effort, another fairly high effect size. So agents who exerted efforts to prevent perceived a notably lower blame in contrast to agents who did not make such attempts. For the final blame judgment, there was a significant main effect associated with prevention effort. And the prevention effort was much more important when attributing blame judgments to human agents than to autonomous artificial agents. So quite similar to intent in many ways. So then the next line of analysis that we wanted to explore was, as it was obvious from the individual factors, some factors exerted a higher initial reaction, so like a higher blame judgment, and some led to a lower blame judgment. So if we just go back to this very last example, prevention effort of yes, when this is the first bit of information you get, we're sort of like trending at around 50. But then later on, irrespectively, it goes up to sort of like somewhere between 70 and 75 or 60 and 75. So it's quite interesting to see like what has happened in a sense, like what are these other bits of information that have resulted in those jumps. And then, I mean, this is a really good example. You have cases where the very first judgment is around 75, maybe a bit more. And then we look at the final judgment, this doesn't change that much. So for some reason, that people that started off with this sort of initial blame judgment of around 75 were happy to keep on holding that level. So this is sort of what we looked into. The first table are mean values. Yeah, so we first investigated cases where the first bit of evidence did not lead to high blame, and the mean values substantiate the notion that participants formulated their judgment based on a threshold principle. So even though there were certain cases such as intent no, desire no, capability high, prevention high, that would create this initial judgment that was sort of in the 50 range, most of them ended up resulting in a much higher final judgment. And what you can look at is you can look at people's judgment after being exposed to these other bits of information. And in a sense, what that tells you is whether that gives you a sort of like threshold amount of information that then people stick to. So as an example, you know, somebody can start off with a blame judgment of around 50 when there was no intent. But then when subsequently they're to people having a desire or having low capability, it jumps up to the 70 range. And the final judgment on average ends up at 69, which is more closer to the judgment after seeing information about desire or capability than it is to that initial bit of information. So what this is giving off is this sort of like pattern that people might be getting some bit of information that is almost like giving them a threshold amount of info that satisfies their search and gets them stuck to a certain range. We can also explore the opposite. So we can explore cases where blame from the jump was pretty high, right? So 74, 66, 78. So quite different from the 40-something, 50-something range. And here we see that the first and the final judgments are far more similar. So it seems like these are cases where people earlier on got the information they were looking for. And it's going to be quite interesting in future versions of this game where people can replay it a couple of times when we introduce the other three scenarios. And also when we start allowing people to make their final judgment sooner, because what my prediction is from this is that people are very likely going to click on less amounts of information in subsequent versions of the game, which will allow us to start increasingly throwing out certain factors that are sought after less and introducing new things from that framework that I showed you originally. So this is sort of like the method that we're going to use to slowly go through the entire framework. We can slowly put in more and more information. We also conducted a 5-way ANOVA. 5-way ANOVAs are super messy and uninterpretable, but it was quite interesting because we could trace what the significant interactions were. So all the main effects showed significance at a high level. That might be just due to a high sample size, but there was significant interaction, and this is sort of more interesting part, between intention and foreseeability, capability and prevention effort, intention and desire, as well as desire and foreseeability. And now we're going to sort of go through these. So when the agent did not have intention, there was a difference in blame judgment in relation to whether the event was foreseeable, with blame judgment being higher if the event could have been foreseen and not as high if it couldn't. And on the other hand, when there was no intention, the event being foreseen or not didn't make any difference, right? So this was sort of the interaction that was going on here. So it only mattered if there wasn't intention. Same holds true for the interaction of intention and desire. So in the case of an agent not having intention, having a desire led to a higher blame judgment. Well, this was not the case when an agent had no intention. Then we have another set of interaction effects. So when an agent tried to prevent the crash, there was a difference in blame judgment in relation to whether the event was foreseeable, right? It makes sense. You only would prevent something if you could foresee it. With blame judgment being higher if the event could have been foreseen than when it couldn't. And also when an agent did not try to prevent the outcome, there was the event being foreseen or not made difference to the blame judgment, as we can see on the graph. And then the very final interaction effect, so this effort and capability. In the case of agent trying to prevent not being capable led to higher blame judgment than not. And this is not the case when agent did not try to prevent the crash in the first place. I realize there's only 3 more minutes, so I'll end with this slide. For the sake of checking it out, we also just sort of like ranked all 64 experimental groups from highest blame to lowest blame. And we got data on like our highest blame group, which is quite interesting. So it's a scenario involving a human agent who possessed both intention and desire, demonstrated capability, yet the occurrence of the car crash could not have been foreseen, and the agent did not make an effort to prevent the crash. A common trend amongst the top 14 groups was that each scenario featured the agent failing to make an effort to prevent, and conversely, instances of lower blame for the most part encompass scenarios where an agent lacked intention. So what this points out, as well as some of the other analysis, is that effort to prevent and intention were probably the most important factors. So I'll leave it at the summary. I think it's probably good to end for the sake of time.
So can you go back to the slide?
To the 64 group slide?
Yeah.
Absolutely.
Yeah, so the highest blame judgment group, the description says, yet the occurrence of the car crash could not have been foreseen. Well, if it could not have been foreseen, like, is it the thing that people blame, like, minus or something?
Yeah, the occurrence of the car crash could not have been foreseen, and the agent didn't make an effort to prevent.
I'm also like, I'm guessing maybe there's like a typo here where it should be could have been foreseen because.
No, I think that was, yeah, thank you for pointing it out. I think that is a spelling mistake. Yeah, no, it's absolutely, occurrence of the car crash where it could be foreseen. Yeah, sorry, that's definitely a mistake. Thank you for pointing that out.
Yeah, because it's also weird to have an intent for something that you can foresee.
Yeah, definitely. No, that's a spelling mistake. Yeah, thank you for pointing that out.
I have a similar style of question, actually. If you go back, pull those slides just before the interactions, when you have the order. Yeah. So I think it's really interesting to what happens and try to think through that first row. So the intention is yes, but if they try to prevent, so prevention yes would be they also try to prevent it. Like that's really interesting. How do people think of that, or how were you thinking about it? That feels like it's cancel it out. Like I really wanted to happen, but then I also tried to prevent it.
Less than excited about.
Yeah, and then they get less. It looks like they get less blame. I don't know. Help me think through that. I'm just interested in what happened there.
Yeah, it's super interesting. So, like, I mean, effort to prevent has been a really fun thing to study because just it really hasn't been studied at all in the previous literature. It was an addition of one of my collaborators, Bertram Malley, who's a professor at Brown, who's really did pave the way for research like this being able to be done in the first place. He really did like identify a lot of these factors in the first place. And yeah, when we gave this to people in person, AI UK, I think, like when we sort of interviewed them afterwards qualitatively, people almost saw it as a type of retribution. It's almost like people saw it as a type of like mini intent. It's almost like you had one intent and then you like changed your mind last minute and tried to like undo your mistake. So yeah, it is pretty interesting, and it's interesting that it matters more for human agents than AI agents, because there's previous work that shows that people are more willing to forgive humans for their mistakes than they are to forgive a machine if it makes a mistake. So maybe it has something to do with that. I'm hoping to get more insight into this once I start analyzing the qualitative data, because that's the next step. We collected qualitative data for all of this, so hopefully that's going to unveil some more stuff.
Yeah, because one other thing that's interesting, I mean, as your diagram sort of reveals, there are interactions among the factors that vary. So clearly, I mean, if you actually had people rate the level of intention by that second evidence bit, like the level of intention, that would also potentially reduce if you had people score it. So it's obviously, I mean, obviously part of what you're studying are these interactions, but it's more complicated because the variable that you're varying, as the previous discussion pointed out, the factors are not super independent. So the bits of evidence presumably interact as well. So
yeah, no, that's a really excellent point. So we actually tried to do that, and this really disappointing thing happened that we still haven't wrapped our heads around, where we actually, after people made their subsequent blame judgment, we actually allowed them to make inferences about all 5 factors. So we were really interested in them telling us okay, like you made your final judgment, you saw all of this evidence. Now on a scale of 0 to 100, in a more granular way, like could you rate the intent, the effort to prevent of the agent, etc.? And the data just kind of doesn't make sense. And I really do just have to blame us. I think we just like didn't elicit it maybe at the right time in the study. Our logic was to sort of like do it at the end because people make their final judgment and they make sort of their kind of like final analysis and conclusions. But maybe what we're going to need to do in the future versions of the study is to get people to make these direct inferences as the information comes in. So yeah, we weren't able to really, it was just for some reason, the current data doesn't make sense, but we're hoping to be able to do that.
Because you're asking for a lot of the subjects to keep track of.
Yeah, for sure.
I wonder if there's place for recency bias.
Mm.
I only saw the beginning of the presentation of the actual game, but I think the questions were asked sequentially, and every time you were allowed to adjust that slider underneath. Look at something like intention, yes, I see that. I set my slider to high. And then as I'm going through these questions, that next one is say, or a few questions down the line, I see prevention. And I see that the person tried to prevent it. And then I have the option to change the slider right away. And at this point, I'm mostly just thinking about how they try to prevent it as opposed to being consistent. I wonder if something like that would play a role.
Yeah, I mean, yeah, I guess it would be pretty impossible for one to avoid recency and primacy effect. I think our approach was just to recruit a lot of participants and get enough data so that all sorts of orderings ended up occurring. And that was the case in our data. We just got lucky and we had a data set where a sufficient amount of people clicked on intent first or desire first, etc. I think a design choice that also helped is that when you look at these buttons, we would randomize the order in which they appeared for different participants. So it could be the case that a lot of people just clicked on the first button because it was the first button. So yeah, I think with this data set, we were able to avoid some of these things. But when we look at analysis across the whole, when we look at the averages, but within each participant, I'm sure that these things really did play an important role. But I hope it canceled out across the whole study.
Kind of a related question that was kind of bugging me a little bit throughout, is it so in your initial analyses, like maybe if you just go to the next slide, maybe, or the one after, like with your first data slide, yeah, actually the one after, so sorry, I guess, yeah, so your degrees of freedom are like around 500, so how are the groups split? Like, was it based on what they clicked first? Like, I'm just curious what your groups were.
Yeah, so the groups were basically people getting one expression for these 6 different factors, which combined in a total of 64 groups. So, you know, an example of a group would be a self-driving car that has intention but no desire and is good at driving, but couldn't foresee the consequences, but made an effort, right? It would just generate any possible combination, and it resulted in 4 combinations. And we had an algorithm that made sure that we had equal allocation. So we didn't have one group with loads of participants and then other groups have less of them.
I mean, you don't have 60, you have 64 distinct groups of subjects also, or a subject could be in more than one?
It can be in one or experimental groups.
Okay, so most of your effects are between subjects.
Yeah, absolutely. No, sorry, did you say within or between?
I have one question to zoom out. I feel like people, when making, they still really crave I'm thinking like, I had this as like an initial empirical question first, but now I don't know, that's maybe you could just speculate more broadly about how to capture whether people are directly blaming like the vehicle or the algorithm itself, or like the developer of the algorithm or the company behind or something like that. And what are people actually doing when making these kinds of judgments? I think this also gives us an opportunity to bring things like character back into the mix, like a cute Google driving car, or like if you see Tesla, like that
For sure.
might impact the judgment that you make. People are, you know, maybe they want to blame the developer of the algorithm, rather than the actual like the vehicle itself. Just like wildly speculating.
I'm really glad you asked, because this is like what I ran out of time for, but we did get people to make blame attributions to agents that weren't directly in the scenario. that reveals some patterns. So there was a significant difference in blame judgment towards the company associated with the car. So whether the taxi driver was employed by one company or the self-driving car was quote unquote employed by another company, the company that was using the self-driving cars received loads more blame. It's just completely uncomparable. We have one that's sort of in the like 30-ish range, and then one that is like at around 70. And then also, even you got it with victim blaming. So in general, people didn't blame the victim that much at all compared to how much they would blame some other agents, but you would get more blame towards someone who is victim to a AI crime than a human crime. So you definitely get this sort of like need to attach blame to a human mind. And that's definitely something that the previous research has identified. This really good book that MIT Press published called How Humans Blame Machines. And one of the main findings they found throughout their studies was that responsibility is more likely to send upwards towards someone that is overseeing the situation when there's a machine that commits a crime than a human. We also have this data here, which isn't statistical. It's more descriptive because it's not directly comparable. But we even asked like, oh, how much would you blame the human driver's driving instructor in the case of human scenarios? And then in the case of AI scenarios, like how much would you blame the manufacturer or the programmer that made the algorithm? And again, we just see far more blame towards humans in the loop in these scenarios with an AI. So yeah, I think that to some extent, like comments on that question, like I think people do have this tendency.
Okay, we're going over quite a bit to this thing on your side. I'm curious about what you see as next. Like, where do you want to go with this?
Yeah, absolutely. So I mean, the next steps are quite simple. So we need to do qualitative analysis first, just because like stuff like the conversations we had today, like using words like want, understanding these dynamics with effort to prevent, like we'll just get like a final level of validation that will then allow us to really sort of finalize the design of the study. We've already iterated a lot since getting this data. So the game that exists now and the game that existed to collect this data is very different. And we've already made a lot of changes as a result of some of the findings we got, and we're going to keep changing them in response to the qualitative analysis. We then want to develop a method for giving feedback. This is because most of these sort of like serious games, like the Moral Machines game and some other games in the space, go viral because people get these like fun bits of feedback that they then share online, and other people see that they were playing the game, so they want to play it too. So in order to sort of create this like network effect where people want to play it because their friends played it too, we need to develop something like that. So that's in the works at the moment. And then we're going to release the full game free online with four contexts. There's going to be a journalism context where it's like an LLM versus an independent journalist. There's going to be an accountant example. There's going to be an example with industrial manufacturing. The reason why we've picked the four contexts is that it relates to four types of crimes. So we have defamatory crimes to people's reputation. We have physical harm, as is the case with self-driving cars, crime that relates to money, so fiscal crime. And then we have psychological harm. So we're making sure that all four types of outcome get tested out throughout the scenarios. And then we're going to just sort of launch it and collect data and try to really go for a really high number of participants, and then release new versions where certain factors that we're exploring at the moment are taken out, they're replaced with new ones, hopefully collect people's emails so that we can invite them whenever a new version is out, and just have this iterative process where we collect the data we need to then go back to that initial model and see what the errors are in light of the data we've collected.
How are you going to make sure that you have a diverse group of participants for this next round of doing it?
Oh yeah, great question. I'm super lucky in that in my team, we already speak a lot of different languages. So we have Edmund Awad, who is from Syria. We have Carlos from Spain. We have Dad, who is from Serbia. Our illustrator is from Bosnia. So like we're hoping to just like initially use our group to translate it into different languages. That's the approach that the Moral Machines game used. I've also been in contact with someone who wants to translate it to Mandarin. So hopefully we're going to get more people on as collaborators that will help us translate it to different languages. And I think that's the approach we're going to use.
Yeah, I'm just wondering about age, I think is an interesting one. You're probably not getting very many something like this, and I'm just curious, like, is this another example where you wanna try to use something like prolific core, where you can actually kind of, I don't know actually how many old people are on prolific, but like,
Well, sure, I mean, my
Yeah.
range, my age ranges are usually between 19 and 64.
okay, yeah, so because it's just interesting that it would be good to have some demographic data based on who's answering this question. I suspect it's my just hypothesis is skew young and skew specific socioeconomic backgrounds.
That's a really good point. Yeah, I mean, we do have some demographics at the moment. Unfortunately, I didn't bring them with me today. Definitely something that I can send you an email about. But I think a approach is maybe trying to see what type of data we get when we launch this as this sort of like free thing that people do online, and then maybe at the end decide to pay
Yeah.
for the data that's missing. So it might be related to age, it might be related to something else. But yeah, that's definitely a good thing to think about.
It might also be worth measuring people's subjective feelings of exposure to AI.
Definitely.
With it, here in this room, we are in a really place where we actually do a self-driving on a daily basis. It's not normal, but I feel like whether that battery exists or not, we should probably be measuring people think that they are encountering artificial agents, because that might change their reasoning.
That is a great point. I should just add that as a question. Some sort of like AI literacy or just sort of like AI experience question. Yeah, that's a great point. All good?
Yeah, thank you, Matija. It's
Cool.
not
Thank you all for
happening.
your questions. This was super fun. I really, really enjoyed it.
That was Matija Franklin talking about the blame game. Thanks for joining us for an AI Objectives Institute talk. We'll see you next time.